So we have the next speaker ready. It's Scott Jennings, also from, he's from Andrew Goldenberg's lab, and his 3-minute presentation is on robot bed making using object recognition and grasping in AI. The next 3 minutes are all yours, Scott.
Thank you. Hi, everyone. At the ANVIV AI and Robotics Lab, one of the current projects we're working on is a bed making robot that will autonomously go to your bed, make it for you. Isn't that wonderful? The problem with this is that bed making, specifically spreading a blanket on a bed, is a very challenging and unique problem to work through. So with any blanket or fabric for that matter, it can assume any number of arrangements, in fact, an infinite number of arrangements, making an infinite state space object. Because of this, we cannot fully express nor observe the entirety of the state of the blanket in our robot system. Therefore, we can't predict what the action of our robot on the blanket will have on the blanket state, even though we have mathematical models that can approximate what this would do. These mathematical models can account for how the size and material properties of the blankets vary from one to the other, almost as much as the arrangements can vary themselves. For that reason, our lab is looking into methods of state abstraction, which would therefore transform the infinite, undefinable bed state that we're dealing with into something that's more discrete and manageable, easy to work with as a data form. To do this, we start with images of the bed. From these images, we start segmenting them into very specific regions. And these regions are tailor-made to capture the current state of the bed. For instance, we have a region that would indicate the mattress being exposed where the blanket has been peeled back. Or we'd have a region indicating the flat portion of the blanket where the blanket is entirely lying flat, has no wrinkles, kind of what we would expect when the bed is fully made. These segmentations that we're capturing are generated for us by a specially trained segmentation convolutional neural network, similar to what's being used in common object segmentation all around the world. However, for our purposes, our output is actually a segmentation image that we're utilizing to get a simplification of what the current bed state is, with all the same information from a spatial standpoint as a depth image or a point cloud, but with new classification information that gives us a little bit more insight into what the state actually is, and more importantly, how close that state is to the desired state of a bed being made. From this, we can do some further processing, such as determining grasp points on a blanket for a robot manipulator, or going as far as to apply reinforcement learning to start learning how the blanket is going to move and be able to make some small predictions in terms of what our actions are going to do on the bed.
Okay, I guess 3 minutes were over, Scott. Sorry, but I think it was still super interesting. So thank you for giving your 3-minute presentation.